All right, guys, we're moving into section 5.4. This section is usually some people's worst nightmare come to life, long division. Yeah, I used to say long division, and you guys are like, I don't know how to do that. So we'll start with a couple problems of just plain old long division from like 4th grade. And then we'll move into long division with polynomials, so x's and all that good stuff. Yeah, that's what we're doing today. On Monday, I will teach you my favorite way to divide, which is synthetic division, which is like nothing you've ever seen before. It will blow your mind, and it is so easy. But not everything can be done with synthetic, which is why we still need long division. Okay? All right. So long division is our goal for today. Yes, sir? Is there a shortcut? No. No. Nope. This is all you. All right. We're not doing it in your head. You're going to write it down. All right, guys, I need you to be quiet. All right, we're going to start with a couple problems of just long division, just to refresh your memories. I know you guys, it's been a long time. So when you're looking at this, this is asking you, what is 672 divided by 3? Okay, so remember with long division, hang with me. I'm going to kind of talk you through this kind of the long, drawn-out way because I know what's coming. I'm trying to get you to thinking in the right order, okay? So how many times does 3 go into 6? Twice. So however many times it goes in, you write that up at the top, right? And then you're going to multiply 2 times 3, which is 6. And then do you remember what you do? You subtract. Good. What is 6 minus 6? 0. So then we drop down the next parts and we start over, right? You guys remember doing this? Some of you may have only dropped down the 1 number. Probably back when you first learned it, you just dropped down the 7 and kind of started again. How many times does 3 go into 7? Twice. So we put the 2 up top again, and then you multiply 2 times 3, and then we subtract. 7 minus 6 is 1. Hold on, slow down. Drop down the 2. It's imperative that you know the process here, because I move into x's and all kinds of stuff. You're gonna freak out. Okay, so I need you to know the basics. How many times does 3 go into 12? 4. Right up to 4. We multiply 4 times 3, and we subtract 0. So what is 672 divided by 3? It's 224. Or in other words, 3 times 224 equals 672. Okay? Hopefully we'll come back to you a little bit. Well, let's look at the next one. How many times does 4 go into 1? 0. So do I write anything there? No. So then I look at how many times does 4 go into 12? 3. So we write up the 3. We multiply. I need you to make sure you're recognizing this process because I know where this is going next, okay? 3 times 4 is 12. And then what? Subtract. 12 minus 12 is 0. Drop down the next number. And the process starts again, right? It's the same process, just over and over and over. How many times does 4 go into 5? Once. So we write up the 1. Then we multiply. 1 times 4 is 4. And then subtract. 5 minus 4 is 1. Bring down the next part. Bring down the 3. And we start again. How many times does 4 go into 13? 3 times. Then you multiply. 3 times 4, 12. Then we subtract. That's 1. Drop down the next one. We start again. It's the same process over and over and over. How many times does 4 go into 16? 4. We multiply. 4 times 4. We subtract. That's 0. Drop down the next number.
This is so like calming.
How many times does 4 go into 3? 0. We multiply. 0 times 4 is 0. We subtract. We get 3. Drop down the next number. How many times does 4 go into 35? 8. We multiply. 8 times 4 is 32. And then we subtract, and we get 3. There's nothing left to drop down, but I didn't get a 0 at the end. What do I do with the 3? Your 4th grade teachers make me so angry. R3. Does that mean anything mathematically to you? I could keep going with the decimal. I could keep putting zeros, and I could extend the decimal. What if I don't want a decimal? I like fractions. It's 3 over what? It's 3 over 4. Whatever your remainder is goes over whatever you're dividing by. R stands for remainder. Remainder of 3. I don't know why they teach you that, because mathematically, it's dumb. All right. It's 3. I mean, how hard is it to go 3/4? 3 over 4. Yeah, but that's why you guys stink at fractions now. Yeah. Yes, sir. Guys, shh. If I put a 0 right here, does it change the value of my number? No. The only reason I didn't because it was right in the front. Guys, stop speaking. Marks. Yep, because I keep dropping that next number down. I like how Jessica said it's very calming, like just it's the same process over and over and over. Yeah. All right, but the main idea from this, even if you were terrible at long division back in the day, is I want you to recognize what process we were always taking. Right? It was the same process over and over and over until I finally hit a point where I couldn't keep doing it. Okay, Michaela? We're doing long division with polynomials. That's what we're learning today. Let's go ahead and start. All right, so we're using long division. So I want you, f of x, what does f of x mean? It's just a y, it's a Frank, it's his name. That's not, I don't have to worry about that. But I want you to take 6x squared plus 7x plus 2 and divide that by 2x plus 1. Okay? So let's set it up. Guys, stop whining and let me finish teaching you, okay? Set it up in long division form. So I'm taking 6x squared plus 7x plus 2 divided by 2x plus 1. Make sure you're giving yourself space above that radicand. That's called a radicand, by the way, the long division symbol, because we are going to be writing numbers up there. What? Just a row of numbers. Yep. So you just need a little space. All right. Very similar to before, we were like, okay, how many times does this go into this, right? That's what we were always asking. Similar question. I'm only looking at the first part. I know there's a lot going on. Just look at the first term, okay? What do you multiply 2x by to get 6x squared? 3x. That's what goes up top. Okay, I'm going to go nice and slow, little baby steps with you, okay? What did we do after we wrote the number up top? I didn't subtract next. I multiplied. Now, if I'm going to multiply 3x times 2x plus 1, you have to distribute this. So I have to go 3x times 2x, 6x squared. And then I also have to distribute here, 3x times 1, which is 3x. Okay, when I'm multiplying just like I did before, but I have two terms there I need to multiply to. What was your next step? You subtract. Now be very careful. If I asked you to subtract 6x squared plus 3x, and I write it this way, what automatically do? You distribute this, right? What happens to all your signs? They change. So really, instead of me telling you to subtract, usually at this point I tell you to change your signs. So this will change to a minus, and this plus will change to a minus. Because that's in essence what I'm doing. If you're subtracting a whole piece of thing, you have to distribute that negative. It changes all your signs. Now, if you do this correctly, what should happen to this first term? It should cancel out. If it doesn't, you did something wrong, okay? So that first one's going to cancel. And then what's 7x minus 3x? 4x. That one's still positive. I'm only changing the signs in that row that I just wrote down. Michaela? Not necessarily. It depends what the problem looks like. But it was a positive 6x squared that I wrote here, so I changed it to a minus. You always, when you subtract, you change signs. So if I had like a negative 6x squared already sitting there, and I threw a negative in front, it would switch it to a positive. Marcus? That would this would have then been a minus 3x to start with. So when I changed my signs, it'd be a positive. Yep, it absolutely changes it. Don't think that hard on it. Write it down, change your signs. That's one thing a lot of students do. They try to like change their signs as they're originally writing it. Oh, that becomes ugly. Don't do that. Do your math like normal, then go through and flip all your signs. Even I still to this day when I do this, I'll write it down and then I'll go back and you'll see that I've crossed off signs and changed them. Okay, even I still do that. I write it down normal, then I change my signs. All right, let's go again, right? Because I'm not done. So then I start again. The first term and first term. What do you multiply 2x to get 4x? 2. Negative 2 or positive 2? A positive 2. Because I'm going to need a plus 2 going up there. What do I do next? Distribute that. Good. So 2 times 2x. And then 2 times 1 is a positive 2. And then change your signs. So that'll make that a negative 4x. I'll switch that to a negative 2. What's 4x minus 4x? That first term should always cancel if you did it right. And then 2 minus 2? Anything left to bring down? So is there a remainder? No, there's no remainder. So 3x plus 2 is your answer. Now what does that mean? Yeah. Huh, that's the factored form. It's like it's almost like I asked you to factor it, but I gave you one of the factors, like I helped you out, kind of thing. No, you can't just factor it because a lot of these will have very ugly remainders, meaning that they wouldn't have factored in the first place. Michaela? That first term. The first term always will. Is it possible that when I did my math here, this didn't cancel and I had a remainder? Yeah, it's possible I have a remainder. Remainders happen a lot, actually. Let's try another one, okay? We're going to go nice and slow because I know it's a lot at first. So first thing, let's write it up the correct way. So I have x cubed plus 5x squared minus 7x plus 2 divided by x minus 2. All right, make sure you write it with your little Radican. Makes your life a lot easier. All right, and remember we start with just the first term. What do you multiply x to get x cubed? X squared. And what do I do once I write the x squared up top? We distribute. Good. So x squared times x is x cubed. X squared times negative 2. Negative 2x squared. Change your signs. If you mess up anywhere in this process, it's usually right there. You forget to change your signs. And again, you're only changing the signs of just that last line that you wrote down. Yeah? No. If it was negative to start with, it would change to a positive. Just depends what you have, what's going on in your problem. All right, but that first term should cancel if you did it right. And And then what's 5x squared plus 2x squared? 7x squared. Yeah, remember we changed the sign there. Minus 7x plus 2. I have a tendency, you don't have to, but I have a tendency to bring everything down with me because I'm always afraid I'm going to lose something. So I just kind of bring it all back down. And then the whole process starts again. What do you multiply x to get 7x squared? 7x. A positive 7x. And then what do? Distribute. 7x times x. 7x squared. 7x times negative 2. Negative 14x. Then what? Change your signs. So that becomes a minus. That one becomes a plus. First terms, better cancel. Negative 7x plus 14x. 7x, and then bring down the plus 2. And we start again. What do you multiply x to get 7x? Plus 7. 7 times x. 7 times negative 2. Negative 14. Then we change our signs. So that cancels. That gives me 16. I got nothing else to bring down. What do I do with the 16? It's my remainder. 16 over x minus 2. It's a remainder. What should I do with my remainder? Should I just sit it there? Should I add it to it? Be careful with that. If you want to be safe and guarantee you don't mess up your signs, just always put a plus sign in between there. Because what's going to happen is if you have a fraction where you have like x minus 2 over, that was a bad choice, I don't know, over like 3x plus 4. Let's say that was your remainder, and I stuck a minus in front of it. What did I just do to my whole problem? I just switched all my signs. So if you guarantee to put a plus there, I don't have to worry about my signs being wrong. Okay? Always put a plus and you'll go, yep, you'll be good. Real quick, would that have factored then? Is x minus 2 a factor of that problem? Did it divide nicely? No, there was a remainder. So if I factored it, would x minus 2 be one of my factors? No, it would not. That's going to come up as a question later. Is x minus 2 a factor? No, there was a remainder. It did not divide nice. It is not a factor. Oh, that's weird. Does yours look like that on your paper too? My underline went up underneath my exponents. That's kind of funny. Is it? That's really funny. That's one big fraction bar. All right, so it's written slightly different, but does it mean something different? What's fraction bar mean? It means divide, okay? So I'm, again, taking this top part, 3x to the 4th minus 5x cubed plus 4x minus 6, and I'm dividing by x squared minus 3x plus 5. What's going to happen when I distribute now? How many times do I have to distribute it? To 3 things, right? There's 3 parts going on out there. You know, you think like, oh, this one's going to be extra long. It's actually not as bad because you have more dividing out front. So when you distribute, you get a lot more of your pieces all at the same time. So it's not so bad. All right. You guys ready? We're gung-ho, right? What do you multiply x squared to get 3x to the 4th? 3x squared. All right, so then we distribute. Now be careful, we have to distribute to a lot of things here. So 3x squared times x squared. 3x to the 4th. 3x squared times negative 3x. Minus 9x, what? To the 3rd. 3x squared times 5. 15x squared. Then what? Change your signs. So change, change, change. Now I want to caution you right here to be very careful. When I go to put my like terms together, first term, better cancel, or I did something wrong. Negative 5x cubed plus 9x cubed. 4x minus 15x squared. You can't. Be careful, because normally like they line up beautifully and it works. But sometimes you see how it went from to the fourth, to the third, to the first. You see how it's missing that squared term? So a lot of times when it's missing a term, they don't line up perfect. So just be careful. I'm just going to put them in the right order. So minus 15x squared, right, because I still have that, plus 4x minus 6. So just be careful. Some teachers teach you to put zeros, like 0x squared, like as a placeholder in there. To me, it just gets way more confusing when you start throwing that stuff in there. Okay, so just be careful. If they're not like terms, just kind of bring it all down, put them in the right order. All right, we're going to start over. What do you multiply x squared to get 4x cubed? 4x. A positive 4x, so that's right. I write plus 4x at the top. And we'll distribute 4x times x squared. 4x times negative 3x minus 12x squared. 4x times 5 plus 20x. Then what? Change your signs. What happens to your first term? Cancels. Negative 15x squared plus 12x squared. 4x minus 20x. And minus 6. Good. Do I keep going? Yeah. What do you multiply x squared to get negative 3x squared? Minus 3. So there's that question some of you had asked. Is that always going to be a minus when I change my sign? Not always. So we'll multiply negative 3 times x squared. Negative 3x squared. Negative 3 times negative 3x. Negative 3 times 5. Then what? Change your signs. First terms, cancel. Negative 16x minus 9x. 25x. Negative 6 plus 15. 9. Can I keep going? Can you multiply an x squared and make it negative 25x? No, I can't do that. I can't make it smaller. So I'm done. So what's that mean about that? It's my remainder. So we're going to have plus, right? Always add your remainders on. Negative 25x plus 9 over x squared minus 3x plus 5. Whatever it is you're dividing by is always your denominator of that remainder. So is x squared minus 3x plus 5 a factor of that problem? No. There's a remainder. It's not a factor. All right, you guys are pretty up in arms with me right away at the start. How are we feeling now? A little better? A little better? Michaela? Yep. Always write them in standard form. Absolutely. Guys, if you're looking at a problem that's not in standard form to start with, it's never going to work. Okay, rewrite them. So let's go ahead and do that. Let's rewrite it. 4x squared plus 23x minus 16 divided by x plus 5. I'm going to let you guys try this one. It's not real big. It's not real huge. Just give this one a try. All right, guys. Let's go ahead and go through it. Guys. Peyton. All right. What do you multiply x to get 4x squared? 4x. Multiply 4x times x. 4x times 5. Don't change your signs as you go. do it here. So we change our signs. First term should always cancel. 23x minus 20. Bring this part down, and we start again. What do you multiply x to get 3x? 3. Multiply 3 times x. 3 times 5. Change your signs. That cancels. This gives me negative 31. That's my remainder. So plus a negative 31 over x plus 5. So is x plus 5 a factor of that problem? No, it is not. Okay. How'd we do? Did good? Good. All right, so number 5. Well, first of all, a polynomial is a factor if the remainder is 0. There we go. If it doesn't have a remainder, it's got a remainder of 0, then we know it is a factor. All right, it's not a factor if it has a remainder, because that means it didn't divide nicely. All right, so is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5? How do you know if it's a factor or not? We got to divide it, yeah. I know you think, oh, it's a yes or no question, but no, you still got to divide. All right, so let's go ahead and set it up. 3x to the 4th minus 4x cubed, 12x squared plus 5 divided by x squared plus 1. I'm sorry. All right, so let's start our process one piece at a time. What do you multiply x squared to get 3x to the 4th? 3x squared. Then we multiply 3x squared times x squared. 3x squared times 1. Then what do I do? Change your signs. What do I need to be careful of? Yeah, they didn't line up. Because look what you're dividing by. Was it missing a piece? Yeah. It went x squared, then a number. It's missing your x to the 1st. Look at your problem. X to the 4th, x cubed, x squared, 5. It was missing the x to the 1st. So you got some missing terms, so things a lot of times don't line up when you got stuff missing. So 3x to the 4th minus 3x to the 4th cancels. Negative 4x cubed minus 3x squared. Are those like terms? No. But can I put this together with this? Yeah. So I'm going to first write down the negative 4x cubed, though. Right? I know that piece is still there. And then these are actually like terms. They just didn't line up. That's going to give me 9x squared plus 5. So we ended up putting these terms together because those were like terms right there. That's where this came from. You guys with me? My like terms didn't line up. All right, and we start again. What do you multiply x squared to get negative 4x cubed? Negative 4x. Multiply negative 4x times x squared. Good. Negative 4x times 1. Then what? Change your signs. First terms, cancel. Good. These are not like terms. I have a 9x squared plus 4x and plus 5. None of those are actually like terms. Can I keep going? Yeah. What do you multiply x squared to get 9x squared? 9. 9 times x squared. 9 times 1. Then what? Change your signs. First terms. 4x minus 4. Good, because you have, those are like terms. They didn't line up. Can I keep going or am I done? How do I know I'm done? Yeah, I can't make an x squared turn into a 4x. It just ain't happening. So what do I do with my remainder? Put it up top, plus 4x minus 4 over x squared plus 1. Good, and the answer is no. Question was, is that a factor of that? No, it has a remainder, so it's not a factor. 1 to go. You ready? 1 to go. Is x minus 2 a factor of f of x equals x to the 5th minus 32? How do you tell if it's a factor or not? We have to divide it, right? We're looking at whether or not it has a remainder. So let's set it up. X to the 5th minus 32 divided by x minus 2. Hey, it's not long, right? Wrong. All right, let's start. What do you multiply x to get x to the 5th? X to the 4th. And then we multiply x to the 4th times x. X to the 4th times negative 2. Negative 2x to the 4th. Then what? Change your signs. First term? Are those like terms? No. So I have 2x to the 4th minus 32. And we start over. You see where this one's going, don't you? What do you multiply x to get 2x to the 4th? Good. 2x cubed. We distribute 2x cubed times x. 2x cubed times negative 2. Then what? Change your signs. First term? Like terms? Nope. So 4x cubed minus 32. And we start again. What do you multiply x to get 4x cubed? Distribute 4x squared times x. 4x squared times negative 2. Then what? First term? Like terms? Nope. So 8x squared minus 32. And we start again. What do you multiply x to get 8x squared? 8x times x. 8x times negative 2. Then what? First term? Like terms? No. 16x minus 32. And we start again? This is fun, right? What do you multiply x to get 16x? We multiply 16 times x. 16 times negative 2. Then what? Change your signs. First term. Like terms? Yes. 0. Hey! Yay, now we're done. So is x minus 2 a factor of that? Yeah. Yes. Michaela? I have an answer. Okay. What? Mm-hmm. Oh, 1, 2, 3, 4, 5. And this was x to the 5th. It depends what you're dividing by. Like if I was dividing by an x squared out here, that wouldn't work. It just depends what you're dividing by. All right, how are we feeling though about long division? If you take your time, not too bad. How easy is it to mess up a problem? Very easy. And what's going to happen is you guys will work through things and you're like, Miss Olner, this is wrong. Can you look at it? And I'm going to cry a little bit because for me to look at it and find your mistake takes a long time, right? Because you're changing signs and you're switching things, and I mean, I can usually find it, but it's going to take me a while, okay? So just be prepared if you ask me to check something because you got it wrong, it'll take me a bit to find the mistake. All right.